We're solving problem 9 from the 2020 AMC 12B. A 3/4 sector of a circle of radius 4 inches together with its interior can be rolled up to form the lateral surface of a right circular cone by taping together along the two radii shown. What is the volume of the cone in cubic inches? First, let's just visualize what this would look like if it was taped. If it was taped, it's just going to be a normal cone. It's just the dimensions on how we draw it is going to be different. So this 4, when you tape it together to this side, is going to be the slant height. So that's what we have. And in order to find the volume, you need the radius of the base circle and the height. One way you can do that to find the radius is that, well, first you want to find the intact circumference of what's left of the circle. Since we're given like that this is 3/4 of what would be a normal circle, our circumference here would just be the circumference of a normal circle of radius 4. That's 8 pi times 3/4, which comes to 6 pi. That's the circumference of, well, this circle here, which is basically the circumference of this base circle. Now, since we know that that circumference is 2 pi r, our radius is going to be equal to 6 pi divided by 2 pi, or 3. So we now know that the radius is 3. All we want to do is find the height. Now, since this is a cone, this is a right angle if you draw the height to the radii. So when you visualize it in 2D from the side, this just becomes a right triangle. 3, 4, let's call this h. Our desired height is then, we use the Pythagorean theorem, 4 squared, which is 16, minus 3 squared, which is 9, and square root that to get our answer. Height is equal to the square root of 7. Then, by the area of a cone formula, that's 1/3 times a radius 3 squared times pi times root 7. We will get that there's 3 pi 7, so our answer is 3 pi root 7, which is the area of the cone in cubic inches.